Hello, everyone. So it's 10 o'clock. I'd say we're gonna head right into it. So, yes, a very warm welcome to everyone. And I'd like to welcome you to the presentation about individual room control with KNX. My name is Bastian Elsner, and I have the pleasure of guiding you through today's webinar. Our topic today is individual room control, efficient heating with KNX. So is there even a better fitting topic? If I look outside of the window, it's very cold. We had minus 12 degrees this morning. So heating, yes, it's definitely that time of the year that's useful to talk about it. Okay, some general information before we dive into the different topics. So today's webinar is live. So I encourage you to ask as many questions as you want. So I'm here live. We have around about half an hour to 45 minutes together. Also, if you have some questions afterwards, I'll be more than happy to answer those via email. But yes, please make use of the question function so you can ask questions. I will make several breaks during the webinar. Don't worry, it's just 30 to 1 minute, but just to give you some time to ask some questions. So yes, let's make the time we have together as interactive as possible. Okay, if you don't have any questions for now, I'm gonna dive into it. Let's go. All right, just as an introductory question to warm you guys up a bit. So how many of you guys turned down the heat control when you left the house this morning? Feel free to just give a quick signal in the chat. I would be very much interested to know. I can just talk for myself. I did not. But yeah, I feel like probably most of us did not. So yeah, let's talk about a way how we can improve that and make the individual KNX heating room control a little bit more efficient than probably the status quo is right now. Okay, first of all, what do you think? Is the comfort temperature subjective? I'll just go with a bold statement and say yes, it's definitely subjective. So everyone has a different sensation of what warmth really is. Someone feels very comfortable within 20 degrees, someone else needs a pillow and a hoodie or whatsoever because they feel like it's cold. So I think almost everyone can relate to the situation shown in the photo. So yes, as said, the heat sensation of people is very different. Nevertheless, comfort can already be achieved even with comparatively low room temperatures. So what do you need to take into regard when setting up heat control in your building automation project? So first of all, drafts need to be avoided because they are perceived as very uncomfortable. Also, huge temperature differences should be avoided because this all drains sort of the comfort level of the people that work or live in a building. So next we get into the learning goals of today's webinar. So after our webinar today, you'll be able to determine the optimal temperature in different rooms. Next up, you will learn how to apply the principle of individual room control with KNX. Next, you will distinguish and correctly apply different modes of operation and of the different control types. Next up, we will give you a very quick overview of the room controllers that we have in our product portfolio, but also dive a little bit deeper into the actuators and what kind of advantages you have with the actuators that we are offering. Okay. First up, we're going to look at the perfect room temperatures, depending on the room where you're in. Afterwards, we will learn about the principle of individual room control. Next up, we continue with different control types. So there's the two-point control and the continuous controller. Those are two different control modes that we will discuss in a bit more detail. Next up, we will talk about the operating mode and switching in the temperature controller. Next up, we will discuss two-stage heating, and in the end, we're gonna discuss, as already mentioned, the overview of the room controllers that Elsner is offering and also the actuators that we have in our portfolio. Okay, so if you have any questions about the agenda, feel free to type in the chat. If not, if I don't see anything, I will just continue with the presentation. But if you want to go into more detail, remember we are live, so make the most out of the webinar and just interrupt me so we can dive deeper into the topics you are really interested in. Okay. Okay, the first chapter, optimal room temperatures. So here I brought a little graphic for you that I believe displays the way and how room temperatures should be different in different rooms, and that is also one of the biggest arguments for implementing individual room control. Because as you see in the bedroom, the most common temperature is very low in comparison to the bathroom, for example. Also, there's a different temperature in the living room and in the office. So the question is, how can we achieve those differences in a very comfortable and automated mode with KNX? We're going to achieve this through individual room control, and this is the topic of today's webinar. Okay, let's start with the principle of individual room control. Here we see the principal representation of a room temperature controller. So the room temperature controller, which can be seen in the box on the left, records the room temperature and sends a manipulated value to a valve actuator. This is just an example. So the control valve is approached and as a percentage, for example, with 30%. Next up, the warm water then flows through the radiator, through the heating circuit, and transfers the heat to the room. The room temperature can then still be influenced if necessary. So the room controller records the temperature again, and thus a control loop is created. This is the loop we just discussed, displayed here. Also, in the room itself, there are various influences on the room temperature. For example, radiating heat from lighting, electrical appliances, or from people in the room that influence the temperature. So I believe this is a very interesting example. So for example, one person in a room emits approximately 80 to 100 watts. Also, it needs to be taken in regard outdoor temperature and weather conditions. If there's very cold weather that's pushing in from the outside, of course, the heating needs to be increased, and this can be done by the set temperature and the scheme that I just presented. So all these factors that mentioned are compensated by the control system so that the room temperature is kept constant and under normal conditions. So the constant and the normal conditions, if you remember the drawing from before, should be different for each room. You simply do not require the same heat in a corridor than you will need it in a bathroom. And this is important that we have these settings for each room, and this is a huge argument for individual room control. Okay, here we drafted a little example for you to show the schematic in a more graphic way. Those are, by the way, products that we are offering. We will discuss them later in the end of the webinar in the product presentation. So we do have the room controller, our Kala, you can see on the right, and we have the K4 actuator. It's a heating actuator. Okay, let's dive into this schematic. So the Kala room controller that is shown in the graphic compares the set point and the actual temperature and calculates the manipulated value from this. The manipulated value is set in percentage via the KNX bus to the heating actuator. This heating actuator in return opens or closes the actuator or the valve depending on the controller setting. As a result, the heater gives off the heat to the room or stops giving off heat to the room. So this is done so the room temperature is always adjusted to the desired set temperature. The arrows drawn in red show the hot water flow to the heater, and the arrows drawn in blue show the return flow from the heater. So the used or cooler water that gets injected into the heating system again. I will wait a couple seconds on this graphic because I believe there might be some questions. So just a couple seconds and then we continue. All right, no questions so far, so we're gonna continue. Okay, as indicated in the agenda, there are several control types. One of them is a two-point controller, which we will have a look at on the next slide. So the two-point controller is the simplest controller that probably everyone knows. It's displayed on the right. I personally still do have them in my house. So yes, I'm very much familiar with those. 1 second, there has been a question. Give me a minute to read it. Okay, thank you very much for this question. I'm just going to read it out so the group can hear it. So is there any concept for wireless communication as well between actuator and controller? This is something we discussed quite a lot, but there are some hardware challenges that are very hard to overcome. We're still evaluating a concept that might be in development in the next year, but nothing is set in stone. So for now, there's nothing planned fixed, but we're still evaluating options of a radio frequency thermostat, which will help with the desired function. But yeah, thank you for the question. At this point, I will continue with the operation of a two-point controller with hysteresis. In the above example, I have shown the function of the two-point control with hysteresis. The green line that you can see is the set point set by the thermostat, so it's 25 degrees. The red dashed lines shows the hysteresis range, so the maximum value, but also the minimum value. This is the range at which the thermostat switches on or off. We assume a hysteresis of plus minus 1 degree. This means that the controller switches the heating on when the temperature falls below 24 degrees, and it switches it off again if the temperature exceeds 26. So same as before, if you have some questions about this drawing, feel free to ask. I'll just continue, and if there are questions, we can always jump back to another slide. Okay, now we're going to discuss how we can set the hysteresis in the two-point controller. So there's the large hysteresis. Few on and off cycles of the heating valve means sort of a gentle correction of the desired temperature. One issue with this is that the regulation is very inaccurate and not really energy efficient. So the temperature fluctuates around the desired set point at long intervals. Next up, you have the small hysteresis. You have many on and off cycles. Therefore, it's not suitable for heating actuators with relays since they have a certain amount of clicks they can do. So for actuators with relays, the large hysteresis is recommended. The control hits the desired temperature more precisely. This is definitely an advantage of the small hysteresis. Also important to note is that the valve also needs 3 to 5 minutes to open and close. Therefore, it may not work properly if the hysteresis is too small. So if they have to switch all the time, but the actual valves need 3 to 5 minutes to open, then it will not work as desired. Okay, let's move on to the next control type. Let's talk about the PI control. So a PI controller is so-called a continuous controller. For example, the actuating variable can assume any value from 0 to 100. In simple terms, this means that the continuous controller can not only switch on and off, but also sensitively adjust the control variable to the temperature difference in the room. In the above example, I have shown the function of the PI controller, or the continuous controller graphically. So you can see the light blue line. After switching on the controller, the temperature initially oscillates around the set point and then moves closer and closer to desired set points. The room controllers that we manufacture here at Elsner Elektronik, which we will discuss later, have an integrated PI control. Let's talk about the advantages and disadvantages of the PI control and of the continuous controller. So the advantages, the controller regulates continuously, which is a good thing because you can reach the desired set temperature very precisely. There are also some disadvantages. So for example, the setting of the control parameters is more complex. So it's a higher level of automation and also of ETS skills in the long run that is requested to do PI control setting. Also, it must be adapted to the used heating system. So the PI control will change from the used heating system to another used heating system. So it's not always the same PI rule that you can apply. As mentioned before, so there are several differences. So you can't always use the same PI control for each heating system. So let's have a look at this quick overview of the different heating systems. So you have the hot water convector heating. So here the recommended regulation is for a low flow temperature of 30 to 45, pulse width modulation, the continuous controller or 2-point control. At a normal flow temperature, 45 to 70 degrees, a pulse width module control is required. If you do not know what the pulse width modulation means, we will discuss this in the following slide. So I'm just asking for a little bit of patience. Okay, next up, we have the floor or the wall heating. So it's a very inert system. Therefore, the pulse width modulation, continuous control with a long cycle time is required. There's another system that is called the hot water fan heater. So for the control of the water circuit, the continuous PI control is used. So if a fan is switched together with the hot water circuit, a 2-point control is required. Electric heating. So for convector heating, the continuous PI control is recommended, and for fan heating, the 2-point control is recommended. Okay, so now I talked a little bit about the pulse width modulation, and here we're gonna see what this actually is. So for example, our KNX heating actuators, the KNX K4 or the KNX K8, which we'll have a look at later, receives the control value from the continuous controller and converts it to the corresponding pulse width modulation signal. So in the following, we will have a look at how the pulse width modulation really works. So for continuous control, it is necessary that the valve does not only opens or closes completely, but what we can also control is the valve in the various intermediate positions. So this is realized via the so-called PWM control or pulse width modulation control. The valve can move to different valve positions with the ratio of the pulse and the pause time. Small example, please look at the middle of the graph where you see the 50% on the right time. In this example, the ratio between the pulse and the pause corresponds to 50%. So the valve is open to 50%, and this, as mentioned, can be seen in the middle graph. So I believe I do not need to explain the other graphs. I'll wait a couple seconds again in case there is another question. All right, I just see there is a question coming up. 1 second, please. All right, so the question was any impact on the lifetime of the actuator with different pulse width? So with our actuators, it does not have an influence because they have an electronic switching mechanism and not a relay mechanism. With other actuators, I can tell. With ours, not. Okay, I'll continue with the presentation. Okay, next we will deal with the operating mode changeover for room temperature controllers. So HVAC is probably something that you guys are all familiar with. So HVAC stands for heating, ventilation, air conditioning, and cooling. And there's several HVAC operating modes in the KNX world. So most temperature controllers in the KNX area have the so-called HVAC objects. HVAC stands for heating, ventilation, air conditioning, and cooling, as already mentioned. And the HVAC can be used, for example, to lower the temperature on the controller display when a room is not in use. It is also conceivable to lower the heating depending on a period or calendar. For example, to turn off the heating during school vacations. So as you can see in the table here, there's different operating modes. Let's start off with the automatic mode. So it has the value of the KNX object of 0. Next up, we have the comfort mode, standby mode, echo mode, and building protection mode. I'm gonna wait a couple seconds more in case there are questions regarding the HVAC or HVAC. I'm not sure what the international pronunciation is. Maybe someone can tell me in the chat as well. All right, no questions so far, so I'm gonna continue with the presentation. So all the temperature controllers are often controlled via 3 1-bit objects. So as shown in the table above, the operating modes can be switched by means of 3 times 1-bit values. In our products, you can select whether the changeover is to take place via a 3 times 1 bit or via the HVAC or HVAC mode. The values executed as X have no influence on the state of the operating mode. So this can be seen here in the table. Let's discuss the operating mode changeover functionality. So as we all know, nowadays energy consumption plays a big role. So we would like to not only control the heating, but also to make the heating smart. For example, we have the ability to turn on the heating when people are actually present in the room and lower the temperature when they are absent. Another possibility is to lower the heating when the windows are open. So I have shown this here graphically. On the left controller, we can set the operating mode, HVAC, HVAC, priority 2. If the window contact in the room is closed, the detector remains in switch position 0 and no control of higher priority, HVAC 1 is executed. In this setting, the manual setting for HVAC 2 operating mode is executed by the controller. So let's take this example a little bit further. If the window is opened now, the window contact switches to the operating mode, for example, frost building protection, and activates the HVAC operating priority 1. As a result, the present operating mode on the heating controller is uncoupled and no longer active. So if the window is now closed again, the operating mode of the manual setting on the controller is called up again. So this is how you can work with priorities and actually make individual room control very smart and put it on a very high level of automation. So I try to put this example in a more visualizable graphic, as you can see here. So here in this example, again, the room controller Kala is shown. The room controller compares the set point and the actual temperature and calculates the control value. Almost the same as in the example we had a look at in the beginning. The actuating variable is sent to the heating actuator in percentage. This opens and closes the actuator or the valve depending on the specification of the heating system. The Kala has an additional binary input, so via this input, a window contact can be integrated into the control. Via this window contact, the heating system can, for example, lower the temperature to frost protection mode when the window is opened. The heating control can also be controlled smartly via a presence detector. So here, for example, the heating could be switched to comfort when presence equals presence and lowered to standby when presence equals absent. So this is conceivable, for example, in the use of classrooms or even offices. Once again, a couple seconds to have a look at this slide and time to ask some possible questions. All right, let's continue. Okay, now we're going to discuss the two-stage heating. So the two-stage heating is a combined heating with two different heating systems. So for example, the inner heating combined with an auxiliary heater for rapid heating. So for example, you have the underfloor heating, but you also have a wall-mounted heater that should work very well together, as here in this example of the bathroom. So the underfloor heating actually maintains the standard room temperature. If a significantly higher temperature is requested, then the wall heating is additionally activated. The desired room temperature is reached very quickly. That about the two-stage heating. As mentioned several times already, we're going to have a look at the overview of Elsner room controllers in heating actuators. Many of them we all have already seen in today's webinar and the graphic schemes. Let's get into it. So first of all, it's actually one of my favorite series that we ever had, and also definitely a high runner we have in our portfolio right now. This is the ETR 101. So the entire ETR series, we also have switches, by the way, have all an integrated temperature measurement. The ETR 101 also have temperature control. Also, this one is available as a BA2 version, so you have a binary input, for example, for connecting a temperature probe that can be connected to the underfloor heating. Next up, we have the ETR 208. So we have integrated temperature measurement as in all the devices from the ETR series. We have the temperature control, but additionally, we also have switching possibilities. We can dim lights. We can also activate and retract the sunshade or open or close a window. Next up, one of the newest products that we will release and will be available to purchase in Q1 next year is the KNX ETR 102 FC. So the FC stands for fan coil. You have the integrated temperature measurement. Once again, I repeat, as in all the devices from the ETR series, you have the temperature control, but what's special here is that you also have the fan level control. Next up, we're going to have a look at the series Kala. You have seen this one in various graphics during this presentation. So we also have the integrated temperature measurement. So there's an actual NTC within the product. We have the temperature control. We have the switch and dim light possibility. We have sunshade and window. And what I very much like about this product is that we have 4 binary input. So that leaves a room for a lot of creativity and in building automation projects. Also, what needs to be added, this one we do not only have with temperature control, but we also have it with CO2, for example, humidity, and many other features. I just saw there was a question. Give me a second. All right, thank you very much for the question. It's quite an interesting one. So how do you recommend the setup when using two-point control? So actually, you always want to use two-point control if you have 2 different sources of heating. So you have 2 different heating systems. If you remember the example of the bathroom, you have a sort of slow heating system that takes a while to adjust the room temperature, but is able to keep it very steady. For example, the underfloor heating. And you have some sort of more rapid heating system like a wall heater, for example. That is when you should always go for two-point control. Okay, and the next part of the question is, and what about the one-stage heating? So the one-stage heating is actually applicable if you only have one heating system. So if you have several heating systems, then you can use the two-stage heating, the two-point control, sorry. and if you only have one heating system, the one-stage heating is recommended. I hope I could answer your question to satisfaction. If not, please dig deeper and ask again, and I'll try again and try to understand what you are meaning. Thank you. Okay, let's continue in the presentation. So with the Kala series, we do not only have touch options, so we also have the Kala KNX 101. So this Kala also have an integrated temperature measurement and temperature control. Next up, we have the Kala KNX multi-touch T-Light and Sunblind. So within this product, we have an integrated temperature measurement, temperature control. We can switch and dim lights, and we can sunshade or open windows accordingly. One second, another question. There's been one question or a comment, I'm not quite sure. So if the room controller basically gives the room thermostat in KNX signal. So yes, this is right. Our room controllers will basically send a signal via the KNX bus to the actuator, so the heating can be controlled. There has been another comment. So if the installer wants to use only 2-point control or activate the level heating and set the offset to 0. There has been an addition. If the installer wants to use only two-level heating, 2-point control, activate two-level heating and set the offset to 0. Thank you for the comment at this point. Okay, next up in the presentation we have the Nuno. It's definitely one of my favorite products because it's very flexible and allows for a lot of application examples. So this is also a very, very cost-effective product, so at the lower end of the pricing spectrum. So the size is 85 millimeters by 85 millimeters. We have an illuminated display. We have integrated temperature measurements. We have binary inputs, for example, for NTCs or for window contacts, as displayed in the graphics earlier in the webinar. Also, you have the opportunity to use temperature controller with HVAC or HVAC switching. Also, you can realize more pages with the switching functionalities. So this is actually really cool because you can either set up via the ETS if you want to have a 1-gang push button with an integrated thermostat, or a 2, 3, or 4-gang push button. So yes, this is very interesting, and we realized some very, very cool projects with it actually. Yes, if you're interested about the products that we have regarding heating control, also the actuators, feel free to let us know in the feedback form that we're going to send out, but I'm going to say more about that later. Also, all the information that we had today, you can also find on our website. Okay, next up, the system devices, the heating actuators. One of them, the K4, we already displayed in some of the graphics earlier. So we have 4 or 8 times output for 230 volt. We have the pulse width modulation control. So it can actually understand pulse width modulation, which is very handy because no relays are needed, but there's the electronic signal that will control the heating accordingly. So we have a maximum continuous load per channel of 8 watts, an inrush current from max 1.1 ampere per channel. Also, one of the biggest actuators of those advantages of those actuators, and that is also why we designed them that way, is that if necessary, several valves can be clamped on one channel, taking into account the maximum current consumption. A standard heating valve is less expensive than a KNX control valve, thus this saves many costs in a building automation project. Okay, I'm actually at the end of the presentation of the webinar. I just want to extend my thankings. It was very nice that so many of you attended this webinar, also asked very interesting questions. I will stay in the webinar for a couple minutes more. So if you have some questions, would like to go back to another slide, discuss something else, feel free to ask now and we can take some time to discuss those things. Some other topics that I'd like to mention. So after we finish our webinar today, you will receive a feedback form. So this will be sent out automatically, and I would highly appreciate if you could give us some feedback. Of course, I'd love if you give us some compliments, but what I'm really interested in is what we could do better for the next time, that you can take more out of the webinar. This could be, for example, hey, I was expecting to see more ETS screenshots, to have a look in the ETS together. This could be a critique of this webinar. It's actually the third webinar that we are doing within the Elsner Academy, and we're still learning. We're trying to get better, but we definitely need to rely on your feedback. So please make use of the feedback forms that we will send out. We will read all of them and take them into account when planning new webinars. Also, what kind of products are you interested? What kind of solutions would you like to discuss in future Elsner Academy webinars? Please let me know, tell me your wishes, and we will try to see what is possible within the next year. As said, I'll stay a couple minutes longer and get back to you in a minute. Mr. Malik, in case you're still here, so I just read your question. So is there any concept for controlling or changing the set points via the set points or time programs remotely over internet? Yes, this is basically possible in every installation where you can access the KNX bus remotely with several visualization softwares. This is possible also with applications from some manufacturers. We also have something like this in our portfolio. So yes, if you would like to learn more about that, my email address is still displayed. I just saw there is a mistake in my email address. It's actually b.elsner and not b.relsner. Sorry for that, I just realized. Okay, another comment, you pronounce HVAC correctly. Sometimes each letter said or HVAC as you did. We often say PWM for pulse width modulation too. Thanks for running the webinar. You are very welcome, and also thank you so much for yes, for explaining me how to pronounce it. That's very, very useful. All right. So if you have any additional questions, feel free to also ask them in the feedback formula. I thank everyone for participating in today's webinar, and in case we do not have contact regularly, I also wish you a very beautiful festive season and some time to spend with family and friends, recharge the batteries, and an awesome start into the new year. So take care, everyone, and goodbye.